exciting. Next job, gearbox actuation. So this box has the 2 cable operation, and if it was in a front wheel drive car, the cables would run up here, and one cable to this little arm goes in that direction, and then one cable over to this little pivot arrangement which pulls the gate up and down like that. But as you can see, the layout of the cable's not so useful for us. We want the cables to run up somewhere around here. So my current plan is to see if I can basically rotate this whole assembly around like that, so I can actuate the cables from this direction. Not entirely sure if this is going to be possible. So here's the actuation unit out of the box, and the aim is to basically rotate this actuation assembly around 90 degrees in relation to this selector assembly on the other end of the shaft. I was very excited when I first pulled this out and realised that this part down here, which is the main part we need to rotate around, is splined. So I thought, great, we'll be able to pull that punch out and then just walk that around the spline and drop it back down. Unfortunately, on closer inspection, that spline has a missing spline, so it's located in one spot. It's also pinned, so if we rotate this 90 degrees somehow, we still need to drill a new pin through. I've checked it with a drill and it doesn't look super hard. Managed to make a spot there pretty easily, so I don't think it's crazy hard. I think with a good quality drill I can drill through this to replace the pin location. But before we do that, we need to see if we can somehow get clearance on that missing spline so that we can rotate this little part round by around 90 degrees. I think it'll actually be 92 degrees or something, because there's, or 94 degrees, because there's 19 splines there. But that will be close enough. So that's the first mission. Yeah, so totally forgot to turn my microphone on, but I've got the shaft, the selector shafts out of the assembly, and I've mounted it in a ER32 collet block, and I've squared that up to the lathe, and then I've got my Dremel tool mounted in the chuck of the lathe. And yes, the lathe is switched off and unplugged. Now, I can't believe it either, but that totally worked, and I can now index the selector to any position I want on the shaft. In the mill, I've got the our shaft mounted into an ER32 square block, which is in the vise, so hopefully that means it's square to the mill. And then I used the edge finder to center the bar, and then held the bar loosely in the collet while I got the right orientation with a 4mm end of a 4mm drill, which is a very close fit to that hole. And as you can see, it's sliding in and out of that cross-pinned hole very nicely. So pretty confident we're in the right spot. So the plan now is to slide our fitting, I should come up with a better name for this thing, back in place. I've got a gauge block set there to set the depths, and I'll clamp this up. Then we can mill a flat onto it and hopefully drill our new cross hole. Got the our fitting clamped up to our metric 1, 2, 3 blocks, and I'm going to put a little spot face on there so that I can put a little spot drill in before we do a pilot drill. And that is why you need to be extra careful when you're milling your beard. Okay, that was pretty exciting. Anyway, now we've got a nice flat spot there, and I've just gone over that with a really fine file just to make sure that the mill left a good clean finish. Now I've got my favourite spot drill. Let's see how we go. I've searched through all my drills to find a reasonably good quality high-speed steel drill bit. That's a Sutton drill bit. That's 3.9, which is perfect size. It's just under what we're after. So I think we've given ourselves every opportunity to see if this works. Just help out. A bit of cutting fluid. Looking good. In fact, I think that drill bit might be a little bit blunt. I picked it because it still had its factory grind on it. I might have to give it a slight touch up on the grinder. Better. And we're through. Okay, so now we're through the shaft. So the only problem now is if the splines on the other side cause us issues. I might just help it out a little bit. Since that's gone so well, I'm going to push my luck and I'm going to try and tap the last section of the hole. The original cross pin was just wasn't even a dowel, it was a roll pin, because the cross drill hole could go all the way through. In this orientation, I can't drill all the way through because I'll go into the section that runs up against the detent spring, and I don't want to do that. I could just push the dowel pin in and then drill it out if I need to remove it, but it would be nice to be able to assemble and disassemble easily. So I think I'm going to try and tap the last section with an M4 thread. See how we go. Alright, now all we need to do is tap that hole. Only kidding. I think I might be hand tapping that one. I've since realised none of my M4 taps are long enough, so I'll have to order some longer M4 taps. I've busted my bottoming out M4 tap ages ago anyway, so I need a new one of those. But proof of concept, I like it and feel comfortable moving on, machining up the rest of the linkage arrangement. So the mission, remake this unit but with this stand around 90 degrees further around Fortunately, I can't modify this, I don't think, easily. Be better to just make a brand new one. I think milling it out of a solid bit of aluminium might be a bit aggressive, and I don't have any aluminium that big, so I'm going to make it in 3 parts. I'm going to have a circular section, push that into a flat plate, weld it around, then I'll do the finish machining once the welding's done, and then we'll mill out a stand and have 2 bolts going through holding that stand in place. First bit of aluminium for this, so I'll chuck this in the bandsaw and slice off a section. See you in a couple of months. You guys just watch that for me, I'm going to go and have a beer. Small change of plans. Rather than weld the cylindrical piece into the flat plate, I'm going to try and press it in, because I think that the thickness of all the objects might be a little bit big for even my 200 amp welder. So I've roughly cut out a hole with the hole saw on the mill to limit the amount of lathe work I need to do, and then attached the plate to this face plate with some clamps, and I will now attempt to bore a straight hole of some dimension. Not super critical, because I'll match it on the piece I'm turning that will press in there. And I don't want to do too much turning, because as you can imagine, this is a fairly unbalanced load, so I'll be running it relatively slowly. So there we go. So even though I had to run a ridiculously slow speed then, I've ended up with a very nice surface finish. I just added some WD-40 on the last cut. Everything's cleaned up nicely, and I think that will be quite suitable for a press fit. Got our plate now, got our plug. Not sure if you can see it there, there's a very faint line there. That's actually 2 different diameters. It's even hard to feel, but one of them just slides over and then it stops, and there's about a 0.02 millimeters additional material for hopefully a good press fit. And I got that fit as close as I could to help line everything up to keep it square. To give us every chance, I'm going to go and chuck this bad boy in the freezer and heat this up with the hot air gun, and hopefully press the 2 together. Let's do this. Been heating the plate up with the hot air gun. This part has been in the freezer. This is a one-shot deal. Oh, I've already fucked it. Oh, there you go. Thermal expansion has done its job. Let's hope I have got enough of a press fit there. It will normalise in temperature quite quickly. Might as well just double check she's all the way home. Let me get you caught up. Got myself into a bit of a machining zone and didn't do much filming, but it was all pretty basic, but time consuming. Once I'd pressed in this fitting into the plate, I put it back in the lathe and then machined all these features. Got a groove for the O-ring, that's a seat for the spring, another machined diameter for that little plain bearing that's pressed in there nicely, and a spot for the seal on the other side. I also just added a couple of M3 screws to make sure it doesn't come apart at an inopportune moment. So that's our new plate, and then machine up this little little stand to match that bad boy. So now I need to put it all together and work out the location of this stand and then attach it. So I'm going to clamp that arm up. Of course, last time I did this without the camera working, it happened first time. So I've got the shims in the right spot. So that's set the angle of the arm. That should set the location. Now we can undo this, clamp, remove our shims, and we should have a usable gearbox. So very happy with that location. Now I need to work out a way of drilling and tapping this block to this base plate, and it needs to be very accurate. The plan is to drill 2 pilot holes through the top of the plate, then we'll reassemble it and drill back through the pilot holes into the block. So this is the scribe outline of where the block goes. This is how far out the actual gearbox casing sticks out. So I've traced that on the bottom side and then transferred it over to this side. Hopefully I've got it in the right spot. This bolt hole is right in the center line. This one has to be offset clearly to fit the head of the bolt on the other side. The asymmetry is causing the internal issues, but we'll say I did it so that you can only assemble it one way. Anyway, I've got it clamped up in the mill so we can get those holes as square as possible. Use the little center point finder to find those holes. Got this one zeroed on the DRO, so I should just be able to drill both holes and completely ruin the plate. Let's do it. It's a good start. That's the trace I did of the outside of the gearbox casing, so it looks like we're well and truly clear of it. And I didn't drill through my parallels. Bonus! Alright, I reassembled it, took it back to the car, lined up the arm again, clamped it into position, disassembled it, and now I'm back on the mill, and I'm going to spot the that riser block with the drill. I've swung the whole head of the mill all the way around off the side of my table so I can drop that clamp off the side of the table. I'm not going to drill all the way through with the tapping drill for the M8 because I think that setup's a little bit flimsy. This is just to mark the hole location on the block. Okay, that one has bolted up nicely, and I'm going to attempt to drill and tap and ream this one all in one go assembled so I get a really good fit. Okay, I agree that was a ridiculous amount of time spent to drill and tap 2 holes, but I think the time spent was worth it. The fit is very nice. I had entertained the idea of inserting a pin into the block to make sure it couldn't rotate around, but with those reamed holes there's just almost no movement at all. It's just not worth it. And these 2 big M8 cap screws lock that block down super tight. So I'll reassemble the mechanism again, go and just make sure everything's in the right spot. If it's not, I don't know what I'm going to do, but just check it, and then I think we can make this top plate look a little bit nicer. Looking good. Alright, I'm going to mark the end of the gearbox casing, and then we'll trim this plate up and make it look pretty, and then move on to sorting out bolting this linkage together properly. Much neater. I think that's it for the base plate. Time to sort out this little pivoting arm. This block was a bit smaller than this one, so I need to shorten this bearing area, and also need to play around a little bit with the angles of the arms. So I think to the lathe. I've taken the 4-jaw chuck off and I'm back to the Lazy Man 3-jaw. I just want to try and turn this weld bead off, and then I can get in there to shorten that bearing area to account for this slightly thinner block. Also need to change the angle of that arm, just so I don't lose the reference of where that originally fitted. I've put a couple of center punch marks in, which I'm sure I'll turn off with that turning tool. Trimmed the arm down. I think the end float's respectable now. Now I just need to set the angle. And I reckon out there looks pretty good. Got it set up in a couple of V-blocks to help keep it square. It's relatively important for it to be square because it's the bearing face for the end float. See how we go. So a small jump forward in time, but I think we are done. I got rid of the silly purple aluminium quick changer and modified the original arm. I've still got the option of running the original location or the quick change location. Also knocked up the bracket to hold the cable outers. Clearly it's a pretty simple bracket, so it only took me about 25 minutes to make, so I didn't bother filming it. But very happy with the overall results. Everything appears to operate nicely. No extra linkages from the factory setup. The cables now run in the correct direction and have a really clear path to the center of the car. So I'm calling that a massive win, and time for a beer. Thanks for watching.